Hello guys, this is going to be the second video of Simcenter 3D series. In this video, we will talk about the CAD import and geometry preparation. Also, we will talk about the idealized part creation, which we have discussed in the previous video. So if you have not seen the previous video, I'll highly recommend to watch that video first because this video will make much more sense if you watch that video and come here back. Okay, so let's just go through what we'll be doing today. What we'll be doing is, first of all, we'll be importing a CAD model.
Powering on.
Correct. So we'll be importing a CAD model. We'll try to clean up this geometry. I'll tell you why we do have to clean geometry. And then we create a idealized part. Okay. I'll let you know what is idealized part. Before that, why we do the cleanup? That's the first question. So I just have one image which I would like to show you. So this is an image basically which tells you about the accuracy versus the efficiency of the model. Suppose this is a full model, full featured part, which is having all the edges, all the chamfers, all the blends, everything is there. All these edges, blends and all, they try to create the meshes which are very fine meshes, very small meshes that increases significantly the computation time of the system. Whereas if you remove those edges, as what I have shown in the right side, to remove those surface, you are going to reduce the computation time significantly, while the efficiency reduction will be very less. I mean, if you see comparatively, 98% you're getting in the first case, 97% you're getting in second case, but you are saving more than 70% time in the competition. So this is just a symbolic representation. I am not saying that it will happen every time. It depends on model, which model you are using, what part it is, how big the system is, how big the files are, what kind of meshing you are doing. There are multiple other factors that will matter into this subject. But just to give you an insight why we actually do the cleanup. That is the reason we do the cleanup. That is why the model which we give for the manufacturing cannot be the same as the model which we use for the simulation. That is why there are two different models, and that's where the idealized part comes in picture. Okay, let me go back to the Simcenter 3D. What I have done, I'll do is I'll import the model. Okay, I have made one parasolid, and this parasolid is having all the features. I'll put this file in the link in the description, and you can download this thing and you can practice also. So just see, this thing is just some random part. This is of no significance what it is. I am not trying to go to that. This is just a part which is having multiple features, multiple shapes. If you see, there is some slots here, some holes are there, and then again if you go, there is some small holes here, there are some blends here. Okay, there are some small holes on this side also. So all this part is basically a part what we use to manufacture. Okay, now I'll just go through the process. Okay, in the process only I'll explain what is the idealized part. So as previously I had told, we'll go to application, we'll go to pre-post, and we'll assume for now that we are going to do some kind of a structural analysis to this part. Okay, so we'll create a FEM model, a new FEM file, and we'll take Nastran only. Okay, and then we'll click OK. So when you are doing this thing, there is a checkbox that comes here and says create idealized part. We'll always check that thing. Okay, I'll show you what it means. So when you click OK here, and then you go to the simulation file view. Now there are three things if you see. Okay, there is a model one. This is the actual model file. Okay, the part file. Then the next step is model one FEM1 I file. That is the idealized file what we have created. And then this is the FEM file. So this is a stage wise happening. Okay. In the next videos, when I'll talk about the simulations as well, I'll tell you what stage means because there will be a sim file also, simulation file. So model one file is the actual part file what you're doing. Model one FEMI file is a file which will be used for computation, which will be used for the analysis without disturbing the actual file. So if you have actually a 3D model which is having all the features and all, and you just don't want to change that part, so what idealized part does is it creates a similar copy of that part which you can edit and use for the computation. That will be easy. So what I'll do is, you can go from here, right click and open in the middle. Okay, it will give you a warning that before you can modify the geometry, you must have to promote and wavelength geometry. It will just create a copy of the system. So at this moment, you just go to promote. Before doing anything, you have to promote it, either promote it or wavelength it. So we'll go to promote and we'll select the body and we'll click OK to it. Okay, now this is a part what basically you have taken and this part now you can rework upon. I'll just do one thing. Before I do this thing, I'll create the mesh file and I'll show you also parallelly how it updates. So in a sequence, if you see, first of all, this is a FEM file, then there is a I file, and there is a model file like the sequence shown here. Okay, in the FEM file, I'll go some random mesh, 3D mesh will generate. I'll take some uh, suggested automatic element size. I'll click OK. I'm not going for the meshing. I'm not showing you anything how to do meshing and all. We'll just assume. If you see near those holes, the mesh is very uneven. This is very rough mesh. Okay, this is very bad mesh. Okay, any place you go to this slot size, this is going to be very inclined mesh. So in mesh quality point of view, it might have some issues. Now this is very simplified model, so you might not have those issues here. But as soon as you go to some different model, you will have different issues. You have some counters and holes here, some chamfers here. So what we do is we go to the I part and we started deleting those things. Now we'll start with delete command as we have done before. We'll go to slot faces. We'll go select these faces, click OK. And the best feature of this thing is as soon as you shift the window, it will give you that your polygon body has been updated. Okay, you just click here and you just click update. Nothing else you have to do. If you do that thing, you see if you compare with the previous thing, this is what is happening. It is all uniform mesh now. Okay, so this is one of the very best feature what I believe Simcenter 3D is having, that it lets you change the model at the same time gets update. I don't think this is a feature for any other software, similar software what we're doing, using for the simulations of such uh, models. So here again, if you see, I'll try to remove this thing also. So if you go here and if you see this side, I'll again try to delete it. Maybe a single face only. Okay, I deleted that here, the blend also. Click OK. So this is one even form of it. And then again, if you want, you can, since the bigger holes will not be an issue because elements are okay. This countersink also you should take out, because there is no point of these things. These are very small features that is only going to increase the mesh size computation time in the system. So if you just click OK to this thing, and what you do is you again, as previously told, you just come back to here. It will tell you that the model is updated. So if you see right now, I have not pressed update yet. The mesh is not uniform around this area. If you see this area, mesh is not uniform. In this area, mesh is not uniform. All these things will be there. As soon as I press update, this will all be fine. See, this is looking way better than before. If you want to go for little more modifications, you simply have to go to the 3D mesh and click automatic element size. It will come back again, and you just press OK. So it will basically, I'll try to reduce further. We'll make it 1 mm. It will make a better mesh only. Yeah, see. So this is going to be a very uniform mesh overall. Computation time point of view also, it will be very generous, and it will reduce the solution time significantly, while the computation efficiency will not be reduced significantly. It will be very minimal change in the efficiency, but your computation time will be having a huge margin difference. So this is what the significance of an idealized part. This is the very first step when you have a model. The first thing you do, you clean up the geometry. You have to clean up. You have to convert this manufacturing model into basically simulation model, a model over which you can run the simulation. So this is very important. I'll say the most of the time people spend in the cleaning up the model rather than the setting the boundary conditions and solving the model. This should take more time, because eventually your simulation time, your simulation efficiency depends totally on these things. So I'll highly recommend you understand this feature. This is very small example what I have given to you. This will have different application, will have different chamfers, counters and holes and all these things. We have to remove all those things. There's no point of using those things unless necessary, unless like there is a bolted joint connection and all. That is a different case. But for a simplified part, you just have, there is a plate, suppose which are having 100 holes. If you're doing the meshing in that plate, there is no point of basically if you do that thing also, there is no point to solve the entire plate with those commands. So what will happen is you will only increase the computation time rather than the maintaining the same computation efficiency. So I'll suggest you always go through this idealized part. You work on the simplifying the model as much as possible, and then be done with it. All right. So in next video we'll talk about the FEM file in details. I hope there is no issue in the idealized file idealized conversion. And if there is any issue, you let me know in the comment section. So I will be able to answer those queries to you. All right. See you.